So today, I left you yesterday with some questions to look at the end of 3.6. We could have a look at any of those that might have given you trouble. We could also, if you want, look at one or two of the dilution questions that I suggested you have a look at if you finished the stuff on page 155 and 155 through 157. But for the most part, what we do today is really up to you. I'm not going to teach anything new. I'm not going to start chapter 4. The plan is, upon returning after a break, that I'll probably go through a quick synopsis of what you should focus on studying for the test. And then after that class, we will have a review class. You only get 2 classes, I think, first week back. So the plan would be full block dependent. Probably the soonest the test would be the first block. I guess that would be Monday, January 12th, I think. Because I believe we start with day 1, so we need Tuesday, Thursday. And to my knowledge, Monday isn't a shortened block, so I think that's probably the most likely time. Okay. I'm under no delusions that you guys are going to spend any significant amount of time over the break studying chemistry, but look in on it now and then so that the stuff that we've been focusing on doesn't become a dim and distant memory over the 17 or 18 day break, because it will. Okay. The stuff we're doing is, come on in. The stuff we're doing is, every individual topic isn't particularly difficult, but when you take it in its entirety and add the fact that there's going to be a 17-day break, you might be surprised what you lose. So just something to keep in mind. So are there any questions with the ones I asked you to maybe look at on 155 through 157? Yep.
Can we look on number 8 on 155?
Number 8, okay. A glass of cold tap water, a glass of cold water contains 0.45 millimolar of oxygen. How many milliliters of oxygen gas at STP? There's those. All right. That's kind of a goofy question, because Gary says as it warms up, but STP is 0 degrees Celsius. So, yeah, let's just assume that it is an STP, but anything at 0 degrees is not going to generate a lot of bubbles in tap water. But anyway, okay, we could look at this a couple of ways. Quantity does he give you? He gives you a volume, right? 300 milliliters or 0.3000 liters, right? So we've got liters of water, and he asks how many milliliters of gas are in that volume of the water. So we're converting one volume to another volume. Now you could call the water the solution because oxygen is the solute in the water. Does that make sense? So it's water, but let's call it solution, because we have a solute, oxygen, we have a solvent, water, correct? And he wants milliliters of oxygen at STP dissolved in effectively 300 milliliters of this solution, right? So you're converting liters of solution to moles of solute to volume of the gas good? Okay, let's just write that out. And sometimes when you write it out, the calculations make a little more sense. Now let's assume that we can convert 300 milliliters to liters of solution, right? And we have that already. Moles per liter is concentration. And he's given us the concentration in millimolar. So 0.45 times 10 to the minus 3 moles oxygen per liter. That's millimolar, okay? Little m, capital M, right? Make sense? So that's how we get from here to here. So let's put it in scientific notation. Maybe get a little more room here. Through my drawer to find it. Yeah, there's one. Milliliters solution times, that's the concentration. 1.5 times 10 to the minus 4 moles oxygen per liter of solution, right? Now, STP means 22.4 liters per mole, right? Or 22,400 milliliters per mole, right? Still 3 sig figs, 22.4 liters, so 22,400. Or if you wanted to, you could convert it to, you could put liters per mole and then turn it into milliliters after, it doesn't matter, I'm just saving the step. And the volume we have is 0.3000 liters. So he gives us, the concentration is to 2 sig figs. 22.4 liters per mole is to 3. The volume is to 4, so our answer is going to be the 2 sig figs. So that should give you your answer in milliliters. So 0.3 times 4.5 is 1.5 times 10 to the minus 4. So 1.5 times 10 to the minus 4 times 22,400. Not a huge volume, but yeah, that should be the answer to 260. Of course, you could have added 2 steps if you wanted to. You could have gone milliliters to liters, and then liters per mole to milliliters, right? You could, if you wanted to. I just saved a couple steps.
Could you go over question 15 on page 156?
Which number?
15.
15? Takes 145 drops from a pipette to reach the 5 milliliter mark on a graduated cylinder. How many grams of bromide ions are in one such drop of a, that's a good question. Okay, that's 2 wheels. So, we're given a quantity of an iron-3 bromide solution. We want to know how many grams of bromide are in one drop, okay? So 2 chemical species means 2 wheels, and we start with the iron-3 bromide. And we want bromide ions, right? So Remember, it's not just the chemical symbol, it's moles. So, we're given a quantity. We want 1 drop. But that's still a volume, right? So, let's get our volume in, we could do milliliters or liters, but let's say we could find what that was, the volume of a drop, right? And we can, it's not that hard. We're gonna go from milliliters of solution, or if you want liters of solution, same way you did over there, to moles of the solute, because we're given the concentration, right? 0.10 molar. Chemical formula will get us from moles iron 3 bromide to moles bromide. And then we're gonna go from moles bromide to grams bromide. Now, if we were just given the volume of that solution, this wouldn't be that tricky. All right, like we got 50 milliliters of 0.1 molar iron 3 bromide, what mass of bromide is in there? That's not really a challenge, but the beginning of it is. In other words, we gotta find the volume of 1 drop. So it takes 145 drops to reach 5 milliliters, right? So we want milliliters per drop, do we not? Okay, so 5 milliliters is 145 drops. If you do that division, don't you get milliliters per 1 drop? So what would that be? And give me 3 sig figs, it's only 2, but we'll carry an extra one through.
0.0345.
0.0245,
345.
louder?
345.
0.0345? Okay. 0.0345 milliliters per drop. Okay, so that's what we're starting with. But let's convert that to liters, okay? Because concentration is moles per liter, all right? So, how about 3.45 times 10 to the minus 2 milliliters times, in 1 liter, we have 10 to the 3 milliliters. So that's 3.45 times 10 to the minus 5 liters, right? And that's the solution we have. So that goes there, that's what we saw. Okay. And then let's just write that out again as a horizontal sequence, just like we did over here. So according to that diagram, we start with liters of solution. We're going to go to moles of the solute. We're going to go to moles of bromide. All we're doing is following the steps. And then moles of bromide to grams bromide. And I bet you, if I let you finish it, you could do it yourself. The tricky part is getting this, the volume of 1 drop, okay? And a bromide ion is the same mass as a bromine atom because electrons are virtually massless. So, I think you guys could take it from here. In terms of sig figs, we got 3 sig figs in the drops, we got 2 in the volumes of drops, and we got 2 in the concentration, so you want your final answer to 2 sig figs. I'm gonna have to go make another filter. Flying is slowed down. Again, I don't need to see wheels on tests, I just need to see that, right? And then check your answer, see if it's right. I probably wouldn't give you something like that on the test. And I don't even know if Gary would intend it for a test question, but you'll notice that these are at the end of the review, and usually at the end of the review, that's when you should be able to connect some dots. Like this is the end of the entire chapter, okay? Check your answer and it's not right? Or you haven't checked your answer yet?
No, I'm just touching.
So the point behind a question like that is, look at the things you gotta weave together there. How do you get the volume of a drop? Well, look at the units. The volume of a drop should be a milliliter per drop. Well, you're given milliliters, you're given drops. As soon as you have that, you're on the quantity with the iron 3 bromide solution on that wheel. Quantities always go on the outside of the wheel, moles always go in the center. What else? Notice on number 17 that Gary actually brings in the graph idea, right? So moles on the y-axis, volume of solution on the x. All of the questions that I asked you to look at in the dilution chapter can be done with M2 equals M1 V1 over V2. All of them are solving for M2, okay? And if I put a dilution question on a test, as I said before, that will be probably a bonus question. And you guys in pre-calc Calc 12? You got a test next month, don't you? I have it with me even as we speak, because I'm covering the block. I confess I don't quite understand the directions, but I'm sure when I read them to you, you will. What room is that in? 115?
Yeah, it's the classroom.
Okay. Apparently, because I'm such a rigorous teacher, Mr. Power asked me personally if I would cover the class because he's giving a test. It's like, thanks, Joe. I'd love to cover for you in the last day before Christmas. Just let you guys cheat and see what he says. Bad choice? Yeah.
Imagine that.
What else? Probably should take attendance.
Can this take any fucking longer? Why is it still loading? W Chromebook, bro.
Bill's here, Julie's here. Daniel Cartina is not, right?
Oh.
There Daniel is. Olivia is. Samantha. Julian. Claire. Allison. Lauren. Granville. The other Samantha. Bernice. Leanne. Nicole. Cassandra's not here. Is that basketball? Cassandra, she just some holidays, okay. Same difference, right? Yeah. Annika, Christina's not here. Dickus, Alexandria, Annabelle, yeah. Ryan, Ariana, Leah.
What's STP 22? 22.4.
I'm just looking at an old test here from 2010. I haven't read up the most recent one yet, but I'm just looking at variety. So just like I mentioned, number one in the written response is gonna be like the worksheet, all right? Promise. Obviously not that many. Number two is gonna be a formula calculation. It'll be a molecular one with part A and B. So empirical first, molecular second. And this is the logic I was gonna employ, but way back 15 years ago, it looks like I employed the same one. The logic is that, because moles are the central unit of measurement in chemistry, what is around the outside of that wheel? Well, we had volume of a gas at STP, we had volume of a solution, we had grams, and we had numbers. So you can expect a question involving STP. I'm not gonna tell you which, but you can expect an STP question. You can expect a solution chemistry question. That could be describe how you would prepare, or something like we just did where you got this volume of this solution, how much of this is in it, that type of thing. And again, I don't need to see graphs, I don't need to see wheels, as long as I see the calculation. When we talk about solution chemistry, remember there's three variables. There's volume of solution, there's concentration, and there's the moles of solute, so Y, M, and X. Any variation of that theme is possible, okay? Remember, if I ask a describe how you would prepare question, if it's from the solid, then place this mass of whatever solid you need in a graduated container, add water to a final volume of. If I ask you for a dilution question, that'll be a bonus, okay? I didn't do it way back in 2010, but the dilution, one of the dilution examples I gave in chapter 7 was preparing a dilute acid from a concentrated acid. And remember, in that scenario, you do not add water to concentrated acid. So that was a little bit of a different recipe there. But again, with a bonus question, it's not gonna count in terms of the total that I calculate for the test, but however much of it you do, you get marks for. So theoretically, you could get, doing any of the bonus question if you have time is never a bad idea, because it's not gonna cost you if you do it wrong, but it can only benefit you if you do any of it right. Sometimes those marks come in handy. So, yep.
For the multiple choice, is there any of the long calculation questions on there?
No, I don't think I'm gonna give any long calculations. There might be a few where calculations are required, but no, like the three-step two-wheel things, no. That's, if it's only worth 1 mark, it's not fair. And by the way, if I did give a question like that, and you're doing your test, and you see this, and you know it's gonna take a whole bunch of calculations, skip it, come back to it later. It's only gonna cost you, or get you 1 mark, so. But no, I'm not, in grade 12 chemistry, sometimes the answer to that question is yes. But it by no means represents, a large number of questions, right? But there could be questions where, like one-step calculations, how many grams is in this number of moles, or, that type of thing, right? And none of the test is gonna be a surprise, that's not the point. I'm gonna be pretty straightforward on the test, so if you understand the material, you should do fine. For the review class, I can't necessarily guarantee that it'll be a full block, because what I might do the Tuesday we get back is start the review if Thursday is gonna be a shortened block as a result of the Chancellor tournament. I don't know the schedule for the Chancellor tournament. But when we have the review class, if you guys ask all the questions you need to ask, and then you're satisfied and I'm satisfied that you're in good shape, I might start chapter 4. Arguably, none of that will be on the test though, right? So, and you might be happy to know that Gary's contribution to the book ends in chapter 3. So chapter 4 was written by Sherry, and it's done very well. We're not doing all of chapter 4, we're not doing section 4.3. Oxidation reduction is a topic in Chem 12. But you own the book, so feel free to have a read through it if you want, if you're intending on taking Chem 12 next year. I don't know if I'll still be here next year, but if I am, the book that I use for grade 12 is our grade 12 version of the book, all right? And Gary actually did, I think, a better job in a grade 12 book than he did in grade 11 book. How many of you are thinking of Chem 12? If you're interested in what's different about Chem 12 and Chem 11, talk to somebody that takes Chem 12. I think the heavy lifting is probably done more from grade 10 to 11 than 11 to 12. Because when you come out of grade 10, you know nothing. And you gotta start from scratch. By the time you get to the end of grade 11 Chem, you know a little more about what Chem's gonna ask of you. Chem 12 is harder. Mostly insofar as the amount of time you gotta spend outside of class. So, at least the way I teach the course, and I don't know if there's really anyone else anywhere that teaches it the way I do, but the curriculum hasn't really changed since there were provincial exams. And the provincial exams, hundreds of millions of dollars were spent making those tests really good. Statistical analyses, feedback from teachers, sample sizes in the thousands of students to vet questions. And then for some reason, Christy Clark, who was premier back then, decided that they were gonna do away with provincial exams. Any student graduating from BC, when there were provincial exams, could go to any university on the continent and do quite well, because the provincial exams were that good. There was no educational reason to do away with them, I think it was just a political decision. But that's where Meg and Sherry and I met. We've marked provincial exams for about 20 years. Sherry marked them for longer than I did. And that's where the genesis of this book idea came from. My point is that in grade 11, all my test questions I make up. I do them in my head. I'll ask this, I'll ask this, I'll ask this. But in grade 12, all the test questions are provincial exam test questions. So a review class in a Chem 11 course looks different than a review class in a Chem 12 course. In Chem 11, try this number on this page, or I tried this, I got this. But in Chem 12, a review class would be, could we try, number 15, January 2008, in the multiple choice. So what I do when I start Chem, when you guys start in Chem 11, I give you a course outline, I give you a book, right? That was pretty much it, and a lab format sheet. But in Chem 12, you get the course outline, you get the book, but you also get a stack of past provincial exams and links to 2 websites where there are more provincial exams. So when you study for a test in Chem 12, you got to carve out time to look at the provincial exam questions. And that's all I give on tests. And the students say, well, gee, if we look at all the provincial exam questions, I don't know if you could because there's so many, but if you look at a representative number, might you see a question, or might I see a question on the test that was on the provincial exams? And to which my answer is, duh. That's the point, right? That's the point. And we always did very well on provincial exams when they were in play. And the last Chem 12 provincial exam was, I think, August 2010. There were 4 written every year: January, April, June, and August. January for the semestered schools, April for the students that wanted to write it a second time. You could write it 2 times in a year. So for example, if you wrote it in June and you didn't like your grade, you could write it in August, obviously a different test. And then I think what the ministry did, whichever mark was higher, they put that on your transcript. Most students, by the time they finished the full year of Chem 12, did not want to study over the summer for a test, in August, but some did. Yeah. And it's interesting that semestered schools, on average, didn't do as well on their tests as linear full year, only because there's so much stuff. It's really hard to learn it quickly and spend, a long period in a semestered school learning the material. And oftentimes we could tell when we were marking semestered schools because the last unit, a lot of schools just didn't finish it. And yet the kids had to go into a provincial exam knowing they didn't finish that material. And yeah, it sucks. It's a lot easier to graduate from high school than it used to be. It used to be you had to write any senior course, any grade 12 registered course with the ministry had a provincial exam attached to it. You had to write it, and it was worth 40% of your final grade in its original version, beginning in 1984. And if you wanted to apply for a scholarship, then you wrote the 2-hour test, and it wasn't, here's an extra half hour, it's like 2 hours and you're done. You got a half hour off, and then you wrote a scholarship exam, which was a nothing but written response. And then the marks on the scholarship exam would dictate your scholarship successes in post-secondary. And then the geniuses at the ministry realized, gee, the students that are doing well in the scholarship also did well in their normal test. Again, duh. So then they did away with the scholarship because it was superfluous. But you had no choice. If you wanted to graduate from a BC school, you had to write provincial exam. So, but it's a lot easier now. You don't have to. But any teacher any good teacher that I know that's still teaching senior sciences, they still say, okay, if you want to graduate, you got to write a final exam. And some schools just don't even have final exams anymore. And I assume that's why your parents are paying all that tuition, because we still do. I don't know. And if I'm not here next year, I don't know what they're gonna do. But if I'm not here, at some level, I don't care. I would like to think that whatever standards we've constructed remain, but I can't insist on anything when I'm not here. Obviously, if I'm not here, I'm not department head, so, yeah. We'll see. Any other questions? That was a rather long rant. I haven't decided yet if I'm gonna retire. I really haven't. The folks downstairs in their wisdom have decided that, like what often happens when a veteran teacher retires is, like I'm the only one that's taught chemistry, senior chemistry here for the last 35 years. This is my 43rd year doing it. So usually, when a teacher considers retirement, they do part-time for a year. For example, if I decided to retire not next year but the year after, then next year I do part-time. I would teach, because I teach 3 Chem 11 and 2 Chem 12, I would probably do 2 Chem 11, and the teacher that was going to be teaching after me do one of those 3 blocks, and maybe 1 Chem 12, and the teacher teaching that after me might do the other Chem 12 block. I'm just guessing that, but that would be the idea. So that part-time year is a transition year, and then at least the teacher coming in teaching it, even if they I mean, obviously they'd have to have a degree in chemistry, but at least then they know what the course involves. And then I hand it over to them with the reasonable confidence that, they're gonna at least approach it with the same rigor that I did. But for some reason, the folks downstairs have decided they are no longer allowing part-time. So either you wanna come back full-time or you don't come back, which I think is a dumb idea, but there is more than a few decisions they make downstairs that I consider dumb. And let's not talk about advisory. But, in any event, if I decide to retire, that might work itself into the decision. So.